This video is about function operations, starting with adding, subtracting, multiplying, and dividing functions. And the good news is that those four things are really exactly what they look like they should be, especially once you are familiar with the notation, which even that is pretty much what it looks like it should be. So I've got two functions made up here, f of x and g of x, nothing special, just random functions. And we're going to start with addition of functions. And these two notations, these say exactly the same thing. We could say f of x plus g of x, or probably more commonly when we're doing this sort of thing, we would write f plus g of x. But either way, they're saying the same thing, which is just add f of x and g of x together. So if we add them together, we'll get x squared, 2x plus 7x is 9x, negative 5 plus negative 1 is negative 6. So that's f plus g of x. And similarly, subtraction of functions. Again, we've got these two ways of doing the notation. The second one is the one that we would tend to use in this context, but we just subtract them. So x squared, 2x minus 7x is minus 5x, negative 5 minus negative 1, so negative 5 plus 1 is negative 4. So that's addition and subtraction of functions, exactly what it looks like it should be. Let's get into multiplying functions. Again, we've got these two different notations. If we write this first line, f of x, g of x, that means f of x times g of x, the same way that if we just write 3y next to each other, that means 3 times y. There we go. So we've got this meaning to multiply them, or this. Now, we've seen, or you've seen this sort of as a multiplication symbol. When you first learned multiplying, you learned it like that. And then maybe you transitioned to the little dot, and that's what this is. And then later on, you kind of started doing it with parentheses. But this is just a dot that means multiplication. So either way, f times g of x, that's what we would say here. F times g of x means just multiply f of x times g of x. X minus 1, so FOIL that, minus x minus 2x plus 1. And so our final answer would be 2x squared minus 3x plus 1. That's f times g of x. And again, similarly, division. We've got a very similar kind of notation here. We would say f over g, or f divided by g of x. And this just means to divide the two functions. Now, we know when we see stuff like this, especially a quadratic, like we're probably going to be factoring it. So let's see if it's factorable, and if so, if that does us any good. Keep that x minus 4 on the bottom. Okay, so things that multiply to negative 12 and add to negative 1, yeah, that works. Negative 4 and positive 3. And these two factors cancel. And so the final answer to this would be x plus 3. Let's talk now about something different. These are called composite functions, or composition of functions. And first, I just want to point out in the notation here, this is different than what we saw previously with multiply. This is not f of x times g of x. This is g of x, and then that goes through the function f. So for example, if we were doing this with a number, let's just say we had x equals 3, then the first thing we would do here is we'd do g of 3, which would be 3 plus 3 is 6. And then we would have f of that result. So f of 6, which then 6 squared would be 36. So this is different than multiplying the two functions together. This is like doing one function and then taking that result and doing the other function to it. Okay, how do we do these? Well, here's the process that I would recommend, the one that I would tend to use. So I would first write, okay, what is g of x? I'd actually start here. Well, we know g of x is x plus 3, okay? So I'm going to write, that's what this is. It's f of Well, g of x is x plus 3. And what I would actually do probably above that is I would write just the definition of f of x. Okay, the definition of f of x is, I'm going to put this in parentheses just for visual, x squared. So now this just says, okay, that's f of x. What is f of x plus 3? So everywhere we see x, we replace it with x plus 3. And then we can multiply this out. X squared, so that would be plus 3x is plus 6x plus 9. So that would be the result of f of g of x. Remember we got 36 a minute ago when we plugged in x equals 3? So if this truly is the result of doing g of x and then f of x, all right, there we go. If this truly is the result of doing g of x and then f of x, then if we plug in 3 here, we should get 36, just as sort of a conceptual check here. So 3 squared is 9, plus 6 times 3 is 18, plus 9. And yeah, that does in fact equal 36. That doesn't prove anything. It just sort of shows, hey, yeah, this actually worked. This does actually seem to represent what we get when we do g of x, and then we take that result and do f of that. Okay, so let's do the backwards, well, I shouldn't say backwards, just another example here. G of f of x. Remember, this is not multiplication, so this isn't necessarily going to be the same. In fact, it usually won't. This is saying we're going to do f of x, take that result, and then apply g of that. Okay, so I'm going to kind of follow the same thing here. I'm going to say, all right, g of x is defined as x plus 3. What we're looking for is g of f of x. We know what f of x is. That's x squared. Okay, so every place I see x in this line, I'm going to replace it with x squared. And that's it. That's g of f of x. So you can see totally different result. Okay, let's try this again with a couple more. And I also want to introduce one other notation here. So this is f of g of x. This is like a little open circle. Let's first be really clear. This is not the closed multiplication thing. So it's not that. This is an open circle, so different thing. And it just means f of g of x. This is the same thing as writing this. And in fact, this is an easier way to look at it. Like, yeah, we have that notation, but this is an easier way to look at it. If you see f of g of x, not fog, by the way, it's just f of g of x, I would suggest just rewriting it like this, because then we can apply the same process we just talked about. So let's do that. F, and I hope I have enough room here. I'm going to, well, yeah, we'll try it. So f of x is defined as x minus 1 squared. What we're doing is f of g of x. We know what g of x is. It's 2x plus 3. So every place I see x, I replace it with 2x plus 3. So that would be 2x plus 2 squared. We can go ahead and do the math. I'll just come up here. So 2x plus 2 times 2x plus 2. It's 4x squared plus 4x is plus 8x plus 4. And that would be the result for f of g of x. And let's do the same thing with g of f of x. So again, first, I'm just going to rewrite it. I'm going to rewrite it as g of f of x, and I'll follow that same pattern that I've used. I know how g of x is defined. It's defined as 2x plus 3. I'm looking for g of f of x. I know what f of x is. F of x, so I'm looking at this part here. F of x is x minus 1 squared. And so every place I see x, I replace it with x minus 1 squared. 2 x minus 1 squared plus 3. So we'll just have a little math to do here. Okay. 2, x minus 1, x minus 1 plus 3, 2, all right, x squared minus x is minus 2x. Minus 1 is minus 1 is plus 1. It's 3, we're getting there. 2x squared minus 4x plus 2 plus 3. Okay, finally, 2x squared minus 4x plus 5. So that is our final result. So whether I got this notation with the parentheses or this notation f of g of x or g of f of x, which I just rewrote, I followed the same process of saying, all right, let me look at the inner function here. I know what that is, so I'm just going to put that in there and then follow the pattern like we do with any function. We just substitute what we're given in place of x or whatever variable in the original function.